this unit, we're going to talk about polynomial expressions and functions. And going along with polynomials has a lot to do with the rules of exponents and how to use those exponents. So again, it doesn't go away. But today we're going to look at scientific notation first. So for a definition of scientific notation, a number is in scientific notation if the number is in the form of c times 10 to the nth power, but c has to be between 1 and 10. So it can be 1, but it has to be less than 10. So it has to be a single digit. And n, that power of n, is an integer, so a whole number. So it says decimal notation to scientific notation. So it wants us to rewrite these super large numbers or these super small numbers using scientific notation. Now the general rule, guys, is if it's a really large number, you're going to have a large exponent. And if it's a small number, you're going to have a small exponent or a negative exponent. So let's look at number 1 and number 2. A number between 1 and 10 would be 4. It's always that first digit. So we're going to make this 4.789. Right now, our decimal is sitting here at the very end of our number. So in order to make this in scientific notation, we need to move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 place values. So we keep the integers. So we keep 4, 7, 8, and 9, but it becomes 4.789. And if we moved it 9 values, it's going to be 10 to the 9th. So if you took 4.789 and times it or multiplied it by 10 to the 9th power, you would come back with this value that you started with. So a really large number means that we're going to have a large exponent or a positive exponent. So now let's look at a really small number where we have 0.00000067. So in this case, a number that would be between 1 and 10 would be 6.7. So we need to move this decimal 1, 2, 3, 4, 5, 6, 7 spots. And this becomes 6.7 times 10 to the 1, 2, 3, 4, 5, 6, 7. Negative 7. So a small number, negative exponent. Large number, positive exponent. So let's go ahead and fill in the next part of our notes. You guys need to try and do number 3 and number 4 on your own. So scientific notation in decimal notation. So if it's written in scientific notation, and then we have to rearrange it. So let's place a number in decimal notation. We move the decimal the same number of places as the exponent that is given on the power of 10. So if the exponent is positive, we move the decimal to the right. So that's the key there, guys. So if the exponent is positive, we move the decimal to the right. So if the exponent is negative, we move it to the left. So like for instance, if we had 9.332 times 10 to the 6th, it's a positive exponent, so we have to move this decimal to the right. So we have 9 and our 332 still. So that gives us 3 decimal places. We need a total of 6, so we need to add 3 zeros on it. Now our decimal is right here. We just don't necessarily write it. So 9,332,000 would be this value written in standard form because it was a positive exponent. So if it was a negative exponent, we need to move this decimal to the left. So here would be 1, and we need it 3 more. So we need 3 more zeros. And our decimal over here. And you guys can always double check. Okay, 4. 1, 2, 3, 4. That would put it back right where it started. So that's good. So 0.000278. So you guys go ahead, try number 7. And I'm going to move down here and do number 8 and number 9 with you guys. Remember, it's just a matter of following those exponent rules, guys, that we learned in Unit 0. Then we redid in Unit 1. We'll see them again in Unit 3. They don't go away. So if we're trying to multiply these values, so the first one is multiplication, all you do is multiply the actual numbers, just like you normally would say it was 5x cubed times 5x squared. You would multiply the numbers, and the exponents you would add. Same thing here. So we multiply 2.3 times 5.5, and we get 12.65. And then we add our exponents. So -1 and +3 gives us 10 to the second. Now the only trick here, guys, is that your 12 is not a number between 1 and 10. So we need to move that decimal 1 spot to the left. Now be careful. We're doing this backwards. So we're trying to make a smaller number. So if we're trying to move our decimal to the left, that means originally it had to have been moved to the right. So we need to add an exponent. So I like to think of it as if you started with a big number, make your exponent bigger. So we're starting with a bigger number and we're making it smaller, so we need to add to our exponent. So it's going to become 1.265, and it's to the third, times 10 to the third. So if you're starting with a larger number, you have to make your exponent bigger. Starting with a larger number, you have to make your exponent bigger when you move the decimal. So that's it. So in scientific notation, it has to be between 1 and 10. So let's look at the division one. Same rules apply. If we multiply, when we're multiplying, we multiply the numbers. Then when we're dividing these scientific notation values, we're going to divide the numbers also. So what is 4.2 divided by 2.0? So it's essentially just 4.2 divided by 2, so cut it in half. 2.1. And our exponent rules say that when we're dividing the bases, we subtract the exponent. So 9 minus 7 is going to give us 2. And in this case, 2 is between 1 and 0, or 1 and 10, so we don't have to move anything. It is in the correct form. Alright, so you guys need to finish this sheet, or finish this page of notes. There's only 3 that you guys have to do. And then there's a scientific notation practice sheet you guys need to do on school as usual. That's going to count as your check for understanding. So you can do it now, and then go finish the second page of notes, or you can do the second page of notes and then go try it. But that's going to count as your check for understanding for the day. So you'll need to do it and then actually upload it. So go ahead, finish this page, guys. Let me know if you get stuck. I'm going to move on and do the second page with you.